I'll be right with you, gentlemen. I'm just trying to log into things. Let me see. This is College Algebra 1, 2 p.m. Forgot about that. Let's close this out. Manage. Create. Can I just import it? Let me see if I can just import it. Import from another course. Next. Let's see, not that one. Not that one. Not that one. Where is it? This is it right here. Next. It's this assignment import. Let's see. Okay. Done with that. Share my screen. All right. It's a little better in hindsight. Is this one? All right. All right, gentlemen. So let's see. Check one other thing. Okay. Testing. Okay. All right. Let's see. No real announcements. One, I hope that everyone had a great weekend. Hope everyone is doing well. You're up to date. Got some rest and were able to just do whatever you needed to do or wanted to do. Just a random thing. This time, and so they had this exhibit. It was interesting. It was free. The second Sunday of every month is free admission at the Hive from 12 to 4. And so I want to say that exhibit is supposed to be there until about January. So you have a month or two. With our regular business, I want to say that we are exam 2 is officially available now. I want to say it's been available since yesterday at 11:11. With my 9 a.m. when we were kind of going through the study guide, there's an unofficial study guide. It's not an official study guide. It's just a collection of all the possible questions you can run across on the exam. But when I was creating that, I saw these things that said like, what are they called? And then I went on to remove that from the exams from all of my sections. So I noticed that as of this morning, nobody had started, which was good. Made it easier for me to make those changes. But yeah, so exam 2 is available. Is due 7 days from yesterday. So whatever that is. See if I can think of anything else. Okay, and so the plan for today. So today we'll do a review as possible. And then on Wednesday, we'll probably do an attendance quiz. So it's going to be an assignment that's only available during class on Wednesday. And that's just going to be attendance. Probably, I'm leaning more towards 10 questions instead of like 5. So something you complete during class, you got to pass to get attendance credit. And it's that classwork assignment on Wednesday. Okay, so for today, let's go ahead and hop on and imported this study guide for exam 2. It's just a collection of questions pertaining to this topic. It's not for a grade. It's just for you to use it however you see fit. Okay, so let's have item C. Give me a random number between 1 and 90. All right, we'll start with question 20. Right here. Okay. So given this piecewise function, find f of negative 13 and f of 15. So piecewise function, all it is just multiple graphs on one Cartesian plane. But each graph is restricted to some region bound by the domain. So for instance, the first graph is just a flat horizontal line through y equals 3, but it only pertains to those y values corresponding to the x values that are to the right of 0. And then it's negative 3 if x is less than 0. All right, so that one should just be negative 3. I don't know how to, because if x is negative 13, that's less than 0, so that means we use line 2. If we're using line 2, whatever x you choose from line 2, the output is always going to be negative 3. In this case, if we were using line 1, the output would always be 3. Okay, so that one, this part B, or f of 15 means we use line 1. So that output says that it's always 3, so I'm just going to put 3 and keep moving. A chance. So let me hop here. I'm going to open a poll if I can get this to cooperate. Come on. What can we do? There we go, finally. All right, let's go here, poll, this one, watch. Okay, so which graph, and I'm, we got a little time in there that you should be able to see it. And what I am going to do, it was this. Let's see how this one. Okay, this one. Let's see. Come on. All right. So I think I'm gonna just let it ride just to reduce the volume. All right, that'll work for me. Okay, so I'm gonna close the poll. Let's see. Maybe this might be my attendance quiz since the participation is so low. That's all based on my mood. Anywho. Okay, I think I'm gonna just go. Let me see. Ooh, I was about to go with the majority, but I don't agree. Ooh, I don't think anybody got it right. Let me see. To the right, it should be positive. I'm gonna go with D. Okay. Okay, so hopefully you can see why that's correct. It's a lot of this is not really about what's the right answer. It's about why is it the right answer. And for this context, for like this course, right? It's less about getting the answer right. It's more about knowing why is that the right answer, right? So then that way, fool me once, shame on you. Fool me twice, can't get fooled again. Fool me 3 times after peace signs. Load the chopper letter in. I totally butchered that one, but I did a conglomerate, a mashup of 3 different things or whatever. Anyway, what is the domain of the function, right? So the domain is going to be the very left to the very right. So how far left does the graph go? Like if we were to take this image, like if D is the correct one, if we took that image and smooshed it onto the x-axis, what x values would it touch? So notice that in line 1 and line 2, neither one of those are equal to 0. So when x is 0, it's not defined. So it's defined for every other x except 0. So the way we capture that in interval notation is as follows. If we can get this to work. Man, this thing be like throwing tantrums. There we go. Let's see if this needs to be like that. Come on. All right, let's try this again. Negative infinity up to 0. 0 gets the parentheses because, again, we don't from 0 to infinity. Oh, comma. So this is how we would capture all real numbers except 0 in interval notation. Okay. Okay. All right. All right. Or in other words, if we took the image and smushed this onto the x-axis, what x values would it touch? So then to range this image and smushed it onto the y-axis, what y values would it touch? So the possible y values here, there are only 2, 3, and -3 in this case. So we're going to say -3 and 3. My device. Maybe it's my device. I don't know. I might need to reboot it. Okay. 81. Let's go to question 81. So given this f and this g, find each composite function and describe the resulting function. Okay. So like unit 2 or this, sections 1.4. Well, this is really 1.6. Combining functions and composite functions. With combining functions, that was basically doing arithmetic operations on functions. So like adding, subtracting, multiplying, and dividing functions. And then we had this fifth operation called composition of functions. So like, for instance, part A is read as f composed g of x, right? So all it means is f of g of x. It just means the second function inside the first function. All right, okay. So I think I'm gonna just take my notes here. So what I'm gonna do, I'm gonna write f like normal, right? Which is gonna be 9x squared. I'll just start there, okay? But then what we want to do is first replace each x with a blank set of parentheses. So now you see the blank parentheses. Then inside the blank parentheses, we're going to put the second function. In this case, it's going to be 9 times the square root of x. Okay. So all we did for f composed g, we just wrote f like normal. We replace each x with a blank set of parentheses, and then we put the second function into each blank parentheses. Now we're just going to simplify. Okay, so if we continue our notes, 9, let me see, 8, so it's basically 9 times 9 times 9, so that's 729. The square root of x squared should just be x. Okay. I'm going to go with this. All right. So then when it comes to domain of a composite function, there's a 3-step procedure that I recommend. First, we find the domain of the inside function. Second, we find the domain of the, all right. So the domain of the inside function in this case would be the domain of G. The only restriction that we have there is that we can't take the square root of negative numbers, right? So that 9 times the square root of x, that radicand, that x has to be greater than or equal to 0. So the domain of the inside function in this case is going to be x is greater than or equal to 0. The domain of the simplified function, which is at 729x, that domain is all reals. So then if we take their intersection, all reals intersection non-negative numbers was just going to be the non-negative numbers. All right, so from 0 to infinity inclusive. So it should be a square bracket 0 to infinity. Okay. So I know I did that audibly. If anything isn't clear, you have to let me know. Otherwise, you guys are okay. I think you guys are okay. I don't see anything. Okay. Let me see. I'm gonna get rid of this for now. All right, so for B, G compose F. All right, so let's do the same thing. We're gonna write the first function like normal, so it's gonna be 9 times the square root of x. I'm just gonna put 9 times the square root of x, okay? But then now normally I would replace each x with a blank parentheses. I'm just going to use the square root as my grouping symbol in this case. And then into the grouping symbol, we're going to put f, which is 9x squared. Okay. So then we want to simplify. So I think those are both perfect squares. So the square root of 9 is 3. 3 times 9 ends up being 27. The square root of x squared is really, or they'll take absolute value of x. I'm just going to put x for now. If it's marked as wrong, I'm going to come back and change the absolute value of x. Because that squared forces whatever number you put in to become positive. So it behaves like absolute value of x. I'm going to go with this and see what it does. Oh, yeah, okay. So I wasn't sure how they, because sometimes they recognize that and sometimes they don't. But it's fine. Okay. And then the domain of G compose F, okay? So again, inside simplified intersection. So the inside function is F, its domain is all reals. The simplified function is 27 times the absolute value of x, its domain is all reals. So all reals intersection all reals is all reals. So we're gonna do negative infinity to infinity, okay? All right, and then F compose F. Okay, same deal. I'm gonna take some notes here. So the outside function, or the first function is just 9x squared. So I'm just gonna write 9x squared. Then I'm gonna replace the x with a blank set of parentheses. And then into the blank parentheses, we're gonna put another 9x squared. Now we just need to expand, simplify, combine like terms, stuff like that. So it looks like it's going to be 729, right? Nope. Try again. No, I think we're good, right? Because that's 9 squared times 9. Yeah, 729 is fine. That's okay. And then, but it's going to be what? Times x to the power of 4. Okay. And let's get rid of the other stuff. And, all right. So we got it. And then the domain, all right? So the inside function, the domain is all reals. The simplified function, the domain is all reals. So then all reals intersection all reals is all reals. Okay. 9 times the square root. I'll go ahead and put the x for now. Again, we're going to replace the x. Normally I do a blank parentheses. In this case, I'm going to use the square root as my grouping symbol. And then the inside function is another 9 times the square root of x. Okay. So simplify this. Okay, let's take some notes over here. So the square root of 9 is what, 3? So 3 times 9 ends up being 27. We got the square root of the square root. So remember that square root is the same as to the power of a half. So what we really have is x to the power of a half to the power of a half. Right? So then a power raised to another power will multiply. So that really should be x to the power of a quarter. So we can say, let me see, how am I going to do this? What if I do n roots? Yeah. The fourth root of x. All right. Hopefully that makes sense. If I need to write that out, just let me know. But again, let me just kind of reiterate that. So we got the square root of 9 times the square root of x. We can break that apart into the square root of 9 times the square root of the square root of x, all right? Square root of 9 is 3 times 9 gives us a 27. So then that square root is square root. Remember, square root is the same as to the power of a half. So what we really have is x to the power of a half to the power of a half. So a power to another power, we multiply. A half times a half is a quarter. So then x to the power of a quarter is really the fourth root of x, okay? Let's go with that. That's it. Okay. The domain, okay. So the domain of the inside function is our non-negative real number, so from 0 to infinity. And then the simplified, we're doing the even root. We can't do an even root of a negative, so it's still the same thing, the non-negatives. So stay as the non-negatives. So basically 0 to infinity. Okay. All right. Let's generate. Let's go. Right here. Okay, that's fine. So we have g of f of 2. Okay. So I think what I want to do here, actually, I think I already got it open. Playing around with this with the students earlier, my earlier section. Let's just go ahead and enter our f of x. We got x squared minus 2, and this is free. I think we mentioned this before. Okay. Okay. There we go. All right. Okay. So the first one, okay. Go ahead and do that. So g of x, I'm going to put 4x plus 9. Pretty much a repeat what we did in the previous example. But then I'm going to replace my bleed. That's all, folks. The blank set of parentheses, right? And then what goes into minus 2? So x squared minus 2, okay? So then from this point, that's going to give us 4x squared, what is that, minus 8 plus 9, which is ultimately just plus 1. We can just evaluate it from that point. Now that we have g of f, again, a 2 squared is 4, times 4 is 16 plus 1, the answer is 17. All right. Suppose 2, that means the second function inside the first function. So we're going to say g over here. Let's try. I'm just going to try it in decimals. G. Why is it doing that? G of f of 2, 17. You see it right there. Okay. So we did it manually. We had the answer manually before, faster than we can do it in decimals. Right. Okay. So okay. G of negative 3 squared is what, a positive 9 times 4 is 36 plus down with it. Okay. Need to update my attendance. Come on. There we go. Oh. There you go. All right, you guys look okay. Let's keep going. Okay, let's do another question. Why is it like? Okay, let's go to 70, the previous question. So for functions f and g are given, adding, subtracting, multiplying, and dividing functions. Oh man, we might need to write this out because I don't. Whew. So I got a little bit anxious because these are rational functions, right? Like fractions. So getting a common denominator and this, that, and the other. But then when I looked at it again, I was like, oh, praise the Lord, it's already a common. We say f plus g to add fractions. The first we get a common denominator, which again, by the good grace of God, they already have a common denominator. So plus x, or we could say x plus 5 over x plus 4. All right, so we can do x plus. So we say x plus 5 over x plus 4. F plus g. So, all right, so when it comes to rational functions, right, in general, the domain of a rational function, denominator is 0, right? So the only x that makes the denominator 0 here is going to be negative 4. So the domain should be all reals except negative 4. Let's see, all right? Let's see. Okay, same deal. So then we just subtract the numerators. It's going to be 5 minus x over x plus 4. So 5 minus x over x should hold, which is d. Okay. Now if we multiply, okay, so we'll start here. We might have to do a little bit more. The top is, we just multiply straight across. So it's going to be 5 times x to give us squared. So x plus 4 quantity squared. That looks good to me. I think it's the same restriction, right? We can't divide by 0. So the only one that makes that 0 is what, negative 4? Okay, and then f divided by g. So if we say one fraction divided by, are going to cancel, and we're going to be left with 5 divided by x. Okay, so 5 divided by x. Okay, so we still have the original restrictions where, we have to remove any x that makes the denominator 0 from the originals. In that case, we would have to remove -4 because they both, -4 makes 0 in the denominator for both functions. But notice with our final result, another number also makes 0 in the denominator, namely when x is 0. So not only do we have to remove -4, but we also have -4 and 0 should be b. And no, okay. Okay, so then g divided by f, that should be x over 5, so it's basically inverted. Is the -4, because you can put 0 in the numerator but not in the denominator. So this one should be a 35. Like kind of chilly all day, and then now all of a sudden it feels like it's just warming up. So this is really nice. Like these past few days have been nice. For there to be like hurricanes and flooding everywhere, cross bridges as we get to them. Describe the transformation that produces the graphs of g and h. Transformations, right? Root of x. And then a, notice that we added 5 on the outside of our base function, or added a negative on the outside, okay? So, good time. Tower. Like when I feel myself start to yawn from my body position, I just change my body position. Instead of I'll generate energy. I don't know why, but just changing how I'm sitting, changing my posture completely changes my experience. So at least I can try to bring some energy to you guys. So I'm listening interesting stories as best I can and try to bring a special individual to slow down and actually get through this stuff in this day and age. It's not for the faint of heart. It's not for weak individuals. Like, not to say that it's just a beast. Like, it takes a special person to sit down and do this kind of stuff. And I don't really. Let me see. Okay, so we're starting with that parent function. All right, and so when it comes to transformations, all right, I feel like each transformation in and of itself is simple, but because there are a total of 10 transformations, when you do them in conjunction, then it can be information overload. All right. So the best way to kind of mitigate that anxiety or the confusion is through repetition and practice. Practice makes what? Hopefully you're not saying perfect, right? Practice makes improvement. Because if practice made perfect, then we would never have to practice again, right? But what happens when we start practicing? Our skill level goes down. So practice doesn't make perfect, practice makes improvement. Anyway, this fun stuff, okay? So then the other thing I was really trying to say when it comes to transformations, outside manipulations cause a vertical change and they generally follow our intuition. Inside manipulations cause horizontal changes and they're generally the reverse of our intuition, okay? So we are fortunate that both of these manipulations in A and B are outside manipulations. If we add a number larger than, if we add a positive number on the outside, it should move the entire graph up 5. And then if we subtract a positive on the outside of our base function, it should move the entire graph down 7 units. Okay, so I just wanted to give some backstory there. Generate. Why does it keep doing side by side? 32. So here's 33. Okay. It says that the table below shows a recent, say, income tax schedule for individuals filing return. Okay. Write a piecewise definition for the tax due on an income tax of X dollars. Okay. So say that the taxable income is between 0 and 1,500. Then the tax due is going to be 2.5% of the taxable income. So in this context, of means multiply, and percents we usually have to write them as decimals. So then it should be 0.025x. So 0.025x. Okay, for that one. And then between 15,000 and 30,000, $375 plus 5.9% of excess over. So whatever amount is over the 1,500. So I guess we would do x minus 15,000. Let's see. So if we did x minus 15, 1, 2, 3, that's not a 15. So the amount over 15,000. And then we want to take 5.9% of that. So I'm going to do some parentheses. So whatever amount is over that, we're going to say times 0.059. Okay. Plus $375. So we need to simplify here. So plus 375. We need to combine like terms. So I'm essentially taking my notes here, right? So if we distribute that 5.9%, we're going to get 0.059x minus, okay? So then we say that percent times the 15,000 plus 375. So distribute and combine like terms. Hey, Google, what's 0.059 times 15,000 minus 375?
0.059 times 15,000 minus 375 is 510.
So I'm thinking it's a negative 510, right? So $510. Because I forgot to incorporate the negative when I was saying the 15,000. So I just, I think what we did was okay. Okay, I'm going to go with that. If it's wrong, we'll fix it. We'll get to the bottom. All right, I'm going to go with that. Come on. Okay. All right, and then if our taxable income is over 30,000, I think it's going to be something similar for this last part. The excess over 30,000, so same kind of deal. Let's go with this. X minus 30,000. 1, 2, 3. Okay. So that's the amount that's over. We want 6.8% of that. So we're going to say times 0.068. So that'll give us 6.8% of that plus 1260. Okay. So same deal. We need to, expand and simplify, combine like terms. Okay, so that first term is going to be 0.068x. Okay. All right, let's try this. Hey, Google, what's negative 30,000 times 0.068 plus 1260?
Minus 30,000 times 0.068 plus 1,260 is minus 780.
780, okay. Okay, I feel pretty good about these results. They both were similar as far as the second and third. So I just got to get rid of this extra stuff. Okay. All right, let's submit it. Cross our fingers. God is good. Oh man, we only got 5 minutes left in class. What happened to the time? What? How is it time to go already? I know you guys are so sad. All right. Okay. I'm just gonna go ahead and try to wrap this one up. So what's going to be the graph, right? So when x is between 0 to there, it basically has a slight positive slope, and it's basically getting more and more steep. It's just getting more and more steep as it goes on, and it's like 3 checkpoints. Which one could it be? So it should turn at the 15,000. I need to like zoom out or something. Try again. All right. 15. Okay. So, but not over. So when we're at 15, right? Do these two match up? Do these give us the same number? Hey, Google, what's 0.025 times 15,000?
0.025 times 15,000 is 375.
375. Okay. 0.059 times 15,000 minus 510.
0.059 times 15,000 minus 510 is 375.
So they are the same number. So when x is 15,000, the taxable, the what is it called? The income tax should be what, 375, right? So it can't be A because that's like 750. That was too high, that turning point. 375, it could be B. I think C is out because it has the wrong X value, right? It has the wrong X value there. And I think D is out as well because it turns the corresponding taxable income is like 600 or 550, something above 500. So the only one that has that ordered pair that we just found is B. So I'm just going to go with B by process of elimination. I just found one critical point, and that was the only one that it matched. Okay, then for C, find the tax due. So I guess it's going to be the second option, right? It's going to be line 2. So then we would just plug that into the formula that we found for line 2. What is that? 20,000? 721. 20,721. 20,721. Hey, Google, what's 20,721 times 0.059 minus 510?
20,701 times 0.059 minus 510 is 712.539.
712.539. 712.539. Okay, so we're talking money two decimal places, so we should round up to 5.4. Okay, so all I did was plug this into that second equation that we found, and we're good to go. Are there any burning questions before we go our separate ways? Let me, the chat looks okay. I don't think we really wrote anything. Yeah, we didn't write anything. Let me see. Okay, again, because it's an exam week, so Wednesday probably what we're doing, I'll just do an attendance quiz that's only going to be available during class time. More than likely, I'm going to do 10 questions. You can access it only during class time, and that's going to serve as our attendance grade. I'm going to use class time as unofficial office hours. So my intent is to be here during class, like a classwork assignment, and your grade kind of determines your attendance. So like you need to at least pass to get attendance credit. You need to pass, and if you don't pass, then you got to fall. You just have a mercy. Okay. So if there aren't any burning questions, we're going to go ahead and end the session here from one mind to another. Okay, yeah, today what I'm going to do is during class, I'm going to do unofficial office hours. And so there's going to be an assignment on my math lab that's only available during class time for that 15 minutes to get your attendance credit. You can anticipate like 10 questions, use any resource that you want to get it done. And you know, the grade that you get determines your attendance for that day on Wednesday. And then once you're done with those 10 questions on Wednesday, then, you know, have a good weekend.
Okay.
Right? Okay. Yep. Let me see. So yeah, with that, if there are any other burning questions, we're gonna go ahead and end the session here. And from one beautiful mind to another, have a great afternoon, gentlemen. And I will see you. Good luck on your exam during class on Wednesday or office hours or whatever. Otherwise, I'll see everybody on Wednesday. Enjoy your evening. And from one beautiful mind to another, take care. Peace. I'm gonna stay on the line. I'm just gonna mute myself so I'm shot of anybody looking for me.
So the midterm
It's not really a midterm. It's just exam 2.
Okay, that's it. Thank you.
Uh-huh.
But
Siri, turn the TV off.
Diddling or anything like that. They'd be blessed. You would never hear the end of it. The fact that you don't hear that means
Sort of. Won't behave, but that's fine. All right. All right. So let me see. Welcome, gentlemen. So we are. Let me see. So I want to say exam 2 is available right now. It's been available since yesterday. With my morning group, I noticed that this exam had some interactive figures in there. Those usually don't work. So I went on to remove them from everybody's exam. And I think this morning, whenever I looked at it, nobody has started. So multi questions. And so with that, what we're going to be doing today, you know how it goes. We're going to go through as many of the corresponding homework questions together as we can. Yeah. So, and if you have questions, feel free to unmute yourself and we can talk about it. Otherwise, we're going to just kind of hop into the guide. It's basically just a collection of all possible questions that could possibly show up on this exam too. And so you can access this if needed. So we'll start with question 68.
Excuse me.
Go ahead.
Where can I find the study guide? Is
In my
under the
in my math lab at the bottom.
Okay, thank you. So the functions f and g are given. Find each of the following functions and state its domain. Okay. So this is arithmetic operations on functions. So like adding, subtracting, multiplying, and dividing functions. So f plus g of x. Okay, so we're just going to do f of x plus g of x if we combine like terms, all right? So I think the 3x squared stands alone. Get my keyboard to work. So 3x squared. We got a negative 35x plus 1x is going to give us a negative 34x. And then 72 plus negative 9, 72, 62, 63. So positive 63. So all I did was combine like terms there. Okay. The domain. So f plus g. So the domain of f is all reals. The domain of g is all reals. So then if we take their intersection, all reals intersection all reals is all reals. So negative infinity to infinity. F minus g. So this means f of x minus g of x. The main thing here is that we have to be aware that we're distributing a negative into that second function. All right. Okay. Come on. Let's go like this, like this. Okay. So if we say f minus g, I think the 3x squared is by itself. There's no like term with that one. Now we got a negative 35x minus x is going to give us a negative 36x. And then 72 minus a negative 9, so plus 9, 72, 82, so then 81. And so the main takeaway there was we need to make sure to distribute that negative into the second function. Same deal, domain of f is all reals, domain of g is all reals. So all reals intersection all reals is all reals. F times g. Okay. So we need to distribute in like FOIL kind of thing here. So let me see. 3x squared times x is going to be 3x cubed. Let me see. 9 times 3 is negative 27 x squared. Okay. And then negative 35x squared. And then let me see. 10 times 35 would be 350. So 341. So plus 341x. So that times that and that times that. And then what? Plus 72x. So minus, so 10 times 72 would be 720, but that's 9 too many. So 710, 711. 711. Okay. Then we need to combine like terms. So we got a 3x cubed. What is that? 50 plus 12 is 62. So negative 62. X squared. That's a 3. 7 and 4 is a 1, carry the 1. So 413. So plus 413x. And I think the minus 711 is alone. Okay, hopefully we got our numbers right. This one, many opportunities to miscalculate or miss a number. Or, you know, a lot of opportunities to make mistakes here. Check it again. I should write it out. Let me see it here. All right, so if we FOIL 3x cubed, 3x to the power of 3. Let me see. I'm going to go ahead and put my equal symbol to keep it separated. 9 times 3 is 27x squared. Oh, negative 27x squared. Okay. So minus 27x squared. Let me see. There's a 3x. 3 times 9 is 27. Okay. So then minus 35x squared. Double negative is positive, 350, 341. So plus 341x, okay? And then plus 72x. And then minus, let me see, 720, 710, 711. Let me see. I think we're getting the same thing. You see 3x cubed, that's what, 50 plus 12. 62. 7 and 4 is 11, so that's 411. Well, 413. Oh. No, I think we're okay. Yeah, I'm not finding the error. 3x cubed. 9 times 3 is 27. 35x squared. 350, 341. Positive. 72x. 720, 711. I might have to get that one wrong. I'm not seeing my error. Let me see. Siri, what's 341 plus 72?
341 plus 72 is 413.
Siri, what's 27 plus 35?
27 plus 35 is 62.
Yeah, I haven't changed anything. I don't know. I'm not seeing it. Check my syntax. Yeah, I don't know. I don't know why that one's not going through. 3x cubed, we get one more attempt. 9 and 3 is what, 27? I don't know. I'm going to get it wrong. Just get past it because I'm not seeing it. 3x, 413, 387. Those last couple of ones. 387 and 680 and 648. 648. Oh, okay, I can see that. I can see that. I probably did do that wrong. You know what? Because I know what exactly what I did that calculation wrong. I'm gonna redo it because that was my fault. Okay, let's just redo it. I think I see it. Can I just reload it? And again, that's the problem with like doing it in your head. I should have probably used the calculator. I'm gonna just get to the end of it. It's not gonna let me. Yes. Clear all. Oh, it's just not gonna let me. I want to start this from over. This is 68. Let me see if I can get it here. Okay, let me just try to. I'm gonna just kind of force it to be wrong so I can get to the end because I just want to restart it. Okay, let's just try it again. Similar question. Okay. So combine, let's just try it one more time. If I don't get it, then I'll let it go. Okay, 4x squared. Let me see, 46x or plus 46x and 90. All right, let's try it. And then the domain, they're both all reals, so it's going to be all reals. Okay. F minus g, so we got to distribute the negative there, so 4x squared. 45 minus 1 is 44, so plus 44x. 81 minus 9, 72. Okay, that's fine. I'm going to say all reals again, same kind of deal as before. Negative infinity to infinity. Okay. All right, let's try this again. So 4x cubed, 4x to the power of 3, and then 36x squared. Okay. 45x squared. Okay, so I know this is where I was making my mistake. Let me think. Okay. So I would have to subtract another 45. I kept subtracting 9. Okay. So 9 times 4 is 360 plus 45. So then 405. I realized that I was doing wrong. 405. I think that's 405 there. All right, let me see. Siri, what's 45 times 9?
45 times 9 is 405.
Yeah, I think that's where I was making my mistake. So then 81 plus 81x. And then 9 and 81. Yeah, I see what I was doing wrong. Okay. So 729. Okay. And then if we combine like terms, 4x cubed, what is that? 70, 81x squared plus 81x squared. 46 plus 29. Okay. It'd be nice if I could just copy all this. I don't think this works like that though. In case I do make a mistake, I don't have to type it all over again. But we're just gonna go with it. I think I realized what I was doing wrong. I kept doing that mental math wrong, which is fine. We got to the bottom of it. Same deal here. The domain is all reals. So let me see, negative infinity to infinity. Okay. And then, okay, f divided by g. Can that factor? Okay, we need to try to factor this guy. I feel like I should write it out. 4 times 81. Can we find two numbers that multiply? What is 4 times 81? Siri, what's 4 times 81? 324?
4 times 81 is 324.
Okay. We're looking for two numbers that multiply to give us 324 and add to give us 45. Okay. So let me take some notes. I was avoiding it, but let me just write some notes here. And let me start by getting a copy of this guy. And we're going to do f divided by g. We just want to see, can we factor this numerator? stuff is a little bit slow today. Would that work if I crop? Yeah, that's what I want. Okay. So I wanted to showcase completing the square. Not completing the square. AC method of factoring. All right, so we're factoring the trinomial. Let me find my pen. It's up there. Right here, there it is. Okay. So this guy, right? So we want to see, can we factor this guy? This 4x squared plus 45x plus 81. So then when we say A24, okay, so that's a 4. 81 is what, 9 times 9? 4 is 2 times 2, and then 3 times 3 times 3 times 3, right? So that'll give us a 324. So we're going to use this to go through all the factors of 324 and stop at the line that adds up to 45, okay? But those are not the two numbers we're looking for. So then we can do 2, right? If we use a 2, 81 times 2, 162. Okay. Yeah, but these are not the two numbers we're looking for, so we're going to keep going. We can do 3, right? I'm just on the left-hand side, I'm just going 1, 2, 3, right? So if we use a 3, what's left? 27 times 4, 80 plus 32, 112, is that right? But those don't add up to 45 right here. So if we use the 4 times 81, right? That's fine. But those are not the two numbers. They don't add up to 45, so we're going to keep going. There's no 5, so we can't do 5, but we can do 6, right? 6 would be like these two. If we use these two, 20, is that 27? Almost, we're almost there. Hopefully my numbers are good. You know, my mental math is okay. 7, we can't do 7. There's no 7 in that list. Can we do 8? There's no 8, but we can do 9. Right, there's a 9. So if we remove this 9, we got what? 9 times 4 is 36. Okay. So 9, let me see. 9 times 3 is 270 plus 54. I think that's right. Siri, what's 9 times 36?
9 times 36 is 324.
Siri, what's 9 plus 36?
9 plus 36 is 45.
So these are two numbers that multiply to give us the desired 324 and add to give us the 45. So now what we're going to do, we're going to use those two numbers that we just found to rewrite this middle guy. But from this point, I'm going to use a technique. So what you see in purple so far is what I call the AC method, right? When I'm factoring a trinomial, my leading coefficient was not a 1, so I had to say that 4 times 81 to give me that 324. Normally, we're looking for two numbers that will multiply to give us 81 and add to give us 45, and that is a 1. If it's not 1, then we got to say A times C, so 4 times 81, all right? So we found the two numbers that we're looking for. So these two are good. I I'm going to use what's called, I like to call the box method for factoring. So in the box method, from this point, the upper left-hand corner goes our leading term, which is 4x squared. Bottom right goes our constant term, which is 81. And then on the other diagonal, we're gonna rewrite that 45x using the two numbers that we just found. So I'm gonna put my 36. I'm gonna put my 36x here and my 9x here. Okay. So now when we go to factor, like across the top, what's the greatest common factor on the two on the top? It looks like they're both, it's a 4x. Looks like we can factor out a 4x from both of those terms. What's the greatest common factor of the two on the bottom? Looks like we can factor out a 9. What's the greatest common factor of the two on the left? Looks like it's just an x, right? And the greatest common factor of the two on the right, let's see, 9 times 4 and 9 times 9. So I guess it's just 9. So it looks like we can factor out a 9 from the two on the right. So our claim, let me get a copy of this and just duplicate. So now, using that box, our claim is that that guy factors into 4x plus 9 times x plus 9. Right? So the purple along with the burgundy box, that's what I essentially call my AC method of factoring the trinomial. The A times the C generated that purple 324. And then we had to go through all the factors of 324 until we found the line to add up to the purple 45. Then once we found those two numbers, then we built this like box on this burgundy box on the left. The main diagonal, you have the leading term along with the constant term. And then the other diagonal, we use the two numbers we just found and then pull out all GCFs or greatest common factors from each combination. And then that kind of reveals what the factor is. And you can check that this works. Like if we FOIL, we should get the above line. 4x squared, that's going to be what? 9 and 4 is 36, plus 9 is 45, plus 81, right? So, okay, so now that we have this factor, if we said f divided by g, so now we're ready to divide by x plus 9. And then we get our cancellation going. And so that one was fun, right? Because we had to actually write. So we got 4x plus 9. There should be a restriction on the domain. I don't know if I need to type that in or not. But we should say something like x cannot be equal to 9 because we can't divide by, okay, that's fine. So then the domain of f divided by g. All right, so a couple of things here. So our reals, so that kind of holds. But then we have an additional stipulation that we cannot divide by 0. So since -9 makes a 0 in the denominator in the original, we have to remove that. So basically the domain is going to be all reals except -9. Okay, and so we're going to capture that interval notation. So the far left would be negative infinity up to -9. I'm using parentheses, and we're going to say cup or union from -9 to infinity. So in interval notation, this is how we would capture all real numbers except -9. And again, we got rid of -9 because it creates a 0 in the denominator in the original part. Okay, that was a fun one. All right, I don't really want to do any more of those though. It's a little bit tedious. Let's go to question 51. Okay, so this is an example of the stepwise, a step function. So this one, it's called a step function because when it's done properly, this is called the greatest integer function. The way we calculate it, whenever we get an integer, we just take that number left, right? And so again, when you're done, it creates this step function like we see similar here. Okay, so then now we want to apply transformations on the generic. Normally the step function at the origin is filled in, and then at 1, 0, there's an open circle. Is it playing? We subtracted 1 on the inside, so that's going to move our graph to the right by 1. It cannot be C because it looks like C moved the wrong way, nor can it be D. I think D moved the wrong way as well. Then we multiplied the outside by a number larger than 1. So when we were doing transformations, inside manipulations cause a vertical change, and they typically follow our intuition. Did I say inside? Hang on. Let me say that again. So outside manipulations cause a vertical change, and they typically follow our intuition. Inside manipulations cause a horizontal change and are typically the reverse of our intuition. So that multiplying by 3 on the outside should cause a vertical change, and it should follow our intuition. So that's going to cause a vertical stretch. We said it had to be either A or B, and A is the only one that did a vertical stretch of 3. So that one, it would take a little bit of effort to get the backstory on what is. Once you get a sense of what the greatest integer function is, in my opinion, it kind of helps if you track the original point at the origin. Like if you look at the original graph of a greatest integer function, at the origin, and if you go over to the right by 1, which is going to be the point 1, 0, that's going to be an open circle. So then from there, I kind of track that point at the origin if it moves left to right or up and down. That's the main point that I'm focused on to track these transformations. Usually there's some point that you can pick to focus on, like if it's a person on the vertex, something of that nature. So usually you pick a point to track and then just try, once you kind of have a sense, then you just make sure that it all matches up. Okay. So that was an adventure. Let me check on you guys. Close. Okay. So it's not true. Had to have some type of experience here. Something we've talked about is some kind of exposure in the homework to get that. Let's go to question 34. Ho, ho, ho. Oh. Custom tees experience fixed cost of $400 and a variable cost of $5 a shirt. Write an equation that can be used to determine the total expenses encountered by Kara's custom tees. Let X be the number of shirts, and let C of X be the total cost, and then calculate the cost of producing 5 shirts. An equation that can be used to determine the total cost of producing X shirts. Let's read it again. A fixed cost of $400, so that's our fixed cost, and a variable cost of $5 a shirt. So we're going to say 5X. So each shirt is going to cost us $4 each shirt, plus a base cost of $400. I think that might be it, really. Okay. And then if we produce 5 shirts, $425. Okay. You guys, so it's like you guys have gotten different questions. I like what some of these questions I hadn't gotten all day. Like that's why I kind of like this though. It kind of changes up on my end, so I'm not being repetitive. And you should be able to view my sessions with the students earlier. So for the most part, I want to say each class was unique throughout the day. So if you want to see more of this, you can PM today as well. It's actually part of this. I think for the 2 and the 3, I just kept it as one long stream. So you can watch the session with the students from earlier in this video, and you can watch the one from this morning. And they all have been generally unique or different for the most part. So functions f and g are given below. Find each of the following functions and state the domain. I might skip this one. I think we just did one like this. F plus g. Okay, I'll go ahead. I think this one's quick. Rational functions. When we add rational functions, we had to add them similar to the way we do fractions. With fractions, we need a common denominator to add or subtract, and we got lucky because they already have a common denominator. So that drastically simplifies the question. So now with that, we can just add I'm gonna put it as x plus 5 over x plus 1. Submit that. Okay. So the domain of f plus g. So for g, and I think so if we take their intersection, a set intersection itself is itself. So the domain here should be all reals except -1, which is going to be b. If we did f minus g, again, we got fortunate because they already have common denominators. So now the numerator is going to be 5 minus x. The denominator is going to be x plus 1. Okay. And I think it's a similar argument for the domain here, everything except -1. When it comes to rational functions, in general, the domain is all reals except any x and g, okay? So we multiply straight across. The numerator is going to be 5x. The denominator is going to be x plus 1 quantity squared. I think the same restriction on the domain. So if we said f divided by g, so when we say one fraction divided by another, we do keep, change, flip. So if we do keep, change, flip, I think that x plus 1 is going to cancel. And we're going to finish with 5 over x. Okay. F divided by g. So we still have to honor that original restriction where x cannot be -1, but now we're also divided by x, so that means x cannot be 0. So not only do we have to get rid of -1, we also have to get rid of 0, and the only one that does that is a. Okay. And then g divided by x, we should be able to just reverse it. So I'm going to say x over 5. Okay. So I think just the original restriction holds. Can't be -1. The 0 can be in the numerator, but it can't be in the denominator. So only thing we got to get rid of here is -1. We got just shy of 10 minutes remaining. Let's go to question 32. Okay. So the graph to the right shows the particle moving on a coordinate line. Is this here? Okay, we're fine. With the velocity equal to f of t at time t seconds, find the domain and interpret. So the domain of the possible x values that this particle can take, coordinate line, that's fine. The speed, so it's like speeding up, it stays constant, it goes a little faster. stays constant and it slows down, then it decreases its rate of slow down, then it speeds up again, slows down. Then it looks like it goes the other direction. Like it slows down to 0, then I guess it reverses speed, or it's going the opposite direction. Then it speeds back up to 0. Okay. The domain here, the possible x values, look like it go from 0 to 24, or possible values of t, 0 to 24. No, no, no. Endpoints. Right. The square bracket. Square bracket because we can include those endpoints. The domain, the particle's motion is tracked. The particle's motion is tracked from 0 to 24. The particle takes on velocities. I'm going to go with B. Oh, particle's motion is tracked from no. Let's go with B. That's it. Oh, okay, good. Got something here. Let's go to question 27. Okay, I like this one. So this example, asks us to find a difference quotient. So I like it because the difference quotient example I worked with my students earlier, it's like 2 or 3 different forms of the difference quotient. The one earlier was like f of x plus h minus f of x all over h. This one is in terms of x and a, right? So it's a little bit different form. Okay, so let's take some notes here. And this will be our last one for the day. So I was just saying that like you can always pull up that video and see, that presentation from this morning. It's the same question, but it had a different form. All right. So, okay, they gave us the A is 4. So let's go ahead and find f of A. Or in other words, okay, that's fine. So it's going to be f of 4. So 1632. So 36. So then if we were to do f of x minus f of 4 over x minus 4. So that's going to be 2x squared plus x minus 36 over 4, or over x minus 4. So then it looks like we need to factor again. This is another showcase of the AC method of factoring like we did in the other example. So we're looking for 2 numbers that multiply to give us, what is that, 72? So negative 72. 2 numbers that multiply to give us 72. We're going to stop at the line that adds up to 1. I think that's what, 9 and 8. But let me just kind of do it like I did before, just as a showcase. So 72 is what, 9 times 8? Mm-hmm. So that's going to be 2 times 2 times 2 times 3 times 3. And we're going to go through all the factors of 72 and stop at the line that adds up to 1. So first we have -1 times 72, but those don't add up to the right thing. So if this is gone, 9 times 4 is 36. But those add up to -34, so those are not the two. Can we do 3? Yeah, we can do 3. If we do 3, 8 times 3 is 24. But those don't add up to the right thing. We can't do 5, but we can do 6. Wait, 3. Sorry, let's do 4. So if we've used this 4 already, 9 times 2 is 18. 40 plus 32, that's fine. But these are not the two we're looking for, so let's kind of keep going. I'm gonna just work over here. We can't do 5, but we can do 6. Okay, so 6. If we use this, what's left? 4 times 3 is 12. So those that doesn't add up to 1. All right, again, we already know what they are, but you know, I just want, right? So here's the 8. What's left is a 9. And that adds up to a +1, which is exactly what we want. Okay. So then that was the first part. So then now to do the factor, if we use like our box method, like we did before, the upper left-hand corner goes the leading term, which is 2x squared. Bottom right is the constant, which is this guy. And then we're going to rewrite that x using the two numbers that we just found. So again, this x here, so that purple x, we're going to rewrite using the two numbers that we just found. So I'm going to do a -8x here and a +9x here. Okay. So across the top, what's the greatest common factor? Like I said, 2x. Across the bottom, what's the greatest common factor? Looks like there's a 9. On the left, the 2 on the left, what's the greatest common factor? It looks like it's x. And what's the greatest common factor of the 2 on the right? 4, -4. So then the claim is that this guy, let's duplicate. Our claim is that that factors into x minus 4 times 2x plus 9. Okay. Let me just check real quick. 2 times x is 2x squared. 9 minus 8 is indeed 1, -36. Okay. Okay, x minus 4. So then now we have x minus 4 times minus 4. And now these guys cancel. Finish with 2x plus 9. Now we just got to go back and make sure to answer all parts of the question correctly. 2x plus 9. You can do it. I believe in you. Don't restart. Oh, just give me the same one. Oh, come on. Come on. Oh, we might. I don't know if it's going to work. I think we're going to have to. I don't know if we're going to get the same question. We lost that question. So, wow. Oh, that's really showing up. It's making me log back in. I wasn't going that long. Oh man. Yeah, it's honestly kind of been on the fritz all day. Let me just see if I can pull something up. What question were we working on?